100 grams of sodium sulfate reacts with 50 grams of barium nitrate to form sodium nitrate and barium sulfate. How many grams of barium sulfate will form? So let's first write our equation. Sodium sulfate, Na2SO4, crisscross the oxidation numbers, plus we have barium nitrate. Remember, when you crisscross in this case, it goes outside the parentheses. And this is going to form or produce sodium nitrate and barium sulfate. Now we need to balance the equation. I think that should have it balanced. Now the question asks how many grams of barium sulfate will form. It doesn't say anything about a limiting reactant. But when you see here that you have these two values for your reactant, it's up to you to know that you have to find your limiting reactant first. So that's what we have to start with, but this time we're not given moles, we're given grams. And so we must first solve grams to moles to see how many moles are available, and then use the mole ratio to see how many moles we need. Starting with sodium sulfate, we have 100 grams of sodium sulfate. Now to convert from grams to moles, we're going to use the molar mass. This is a little bit longer of a tutorial, and so for the sake of time, I'm just going to let you know that the molar mass, I've calculated it, and it is 142.04 grams per 1 mole. So this tells us that we have available 0.704 moles of sodium sulfate. Now let's check out the barium nitrate. We have 50 grams of barium nitrate. So if we get to grams to moles to see how many moles are available, we're going to use molar mass. Once again, for the sake of time, molar mass, I've calculated it to be 261.34. So this comes to 0.191 moles of barium nitrate available. And remember here, this is the number of moles of sodium sulfate available. Now let's see how many moles we would need to react completely with each of these. And so if we have 0.704 moles of sodium sulfate, we want to know how much barium nitrate we need to react fully with that. So we're going to use a mole-to-mole ratio. We have 1 mole of sodium sulfate to every 1 mole of barium nitrate. So we have 0.704 moles of barium nitrate needed. Oh, it is glitching out again. Here with barium nitrate, we're going to get that mole ratio. 1 mole of barium nitrate to every 1 mole of sodium sulfate. So there's 0.191 moles of sodium sulfate needed. So now let's evaluate this. Here we have 0.191 available, and it tells us we need 0.704. So do we have enough? Is there enough available to cover what's needed? No. So that tells us barium nitrate is our limiting reactant. Now let's check out sodium sulfate. We have 0.704 moles available. We only need 0.191 to react with this number of moles of barium nitrate. So we have plenty here. So this is our excess. Now we can solve for the grams of barium sulfate that will form. And so we're going to use our limiting reactant from here on out. And we can go ahead and we can start with this, the number of moles of barium nitrate that are available. So we have 0.191 moles of barium nitrate available. And so we can go from moles of barium nitrate to moles of barium sulfate. So anytime we're going from one compound to another, we must use the mole ratio. And so we can look here and see we have 1 mole of barium nitrate to every 1 mole of barium sulfate. Now that we're in moles of barium sulfate, we can use molar mass to find the number of grams of barium sulfate that will form. So the molar mass of barium sulfate, for the sake of time, it is 233.43 grams per 1 mole. And now we're ready to calculate, and we will find our answer to be in grams of barium sulfate. So after you make this calculation, you should have about 44.6 grams of barium sulfate formed. This is the last problem on this tutorial, and it asks, you have 25.3 grams of magnesium, and it reacts with 44.3 grams of copper 2 nitrate to form copper and magnesium nitrate. So it wants to know what mass of copper will form and what mass of reactant will remain unreacted. So let's take a look at this equation. We have magnesium reacting with copper 2 nitrate. And it will produce copper, who is now single, and magnesium nitrate. Now to balance the equation, we look and we see it is balanced as is, and so our coefficients are 1. And hopefully if you look, you can identify the type of reaction here. In case you don't know, it is single replacement. So we have 25.3 grams of magnesium and 44.3 grams of copper. Now anytime you have values for both of your reactants, you need to find the number of moles so that you can determine the limiting reactant. So let's start with determining the number of moles of magnesium. 25.3 grams of magnesium. We have to use molar mass straight from the periodic table. Magnesium has a molar mass of 24.305 grams per mole. That is 0. So this gives us 1.04 moles of magnesium are available. Now let's take a look at the copper 2 nitrate. We have 44.3 grams of copper 2 nitrate. Use the molar mass to find the number of moles. For the sake of time, I've calculated it, and it is 187.55 grams. So we have 0.236 moles of copper 2 nitrate available. So now that we see what we have available, we need to determine how much is needed. So we need to see first, how many moles of copper 2 nitrate do we need to react fully with magnesium? So we have a 1-to-1 ratio, looking at the coefficient from the balanced equation. We have 1 mole of copper 2 nitrate over 1 mole of magnesium. That tells us we need 1.04 moles of copper 2 nitrate is what's needed. Now taking a look at copper 2 nitrate, if we wanted enough magnesium to react fully with this, we can see how many moles we would need. Once again, a 1-to-1 ratio, 1 mole of copper 2 nitrate. Now remember, I know to put the copper 2 nitrate on bottom because I want it to cancel out. And magnesium is what I want, so that's what we put on top. This tells us we need 0.236 moles of magnesium. That is what is needed. Now let's evaluate this. For 1.04 moles of magnesium to react fully, I would need 1.04 moles of copper 2 nitrate, but I only have 0.236, so I don't have enough. So this is my limiting reactant. And here we see that we only need 0.236 moles of magnesium, and we have more than that. We have 1.04 moles, and so we have plenty. This is what we'll have excess of. We'll have excess magnesium. Let's look at this first question. What mass of copper will form? And remember, to solve this, we're going to use our limiting reactant. So let's see what we have available from copper 2 nitrate. We have 0.236 moles of copper 2 nitrate available. So to calculate and convert moles of copper 2 nitrate into moles of copper, we have to use our mole ratio. So using the balanced equation, 1 mole of copper 2 nitrate is equal to 1 mole of copper. Now that we are in moles of copper, molar mass. So straight from the periodic table, 1 mole of copper has 63.546 grams of copper. So this will get us our answer for this first one here. And it is 15 grams. 15 grams of copper. The second part asks what mass of reactants will remain unreactive. This is a different type of question than we've seen before. It wants to know what mass of the excess reactant will remain. So our excess reactant is magnesium. So now we have to figure out something new. How much was left over since it did not fully react? Let's see how much excess magnesium we have. We have 1.04 moles available, but we only used 0.236. So how many moles do we have left over? Should have been 0.804 moles of magnesium left over. So we're almost there. It wants to know the mass. We're at moles. So now all we have left is a mole to mass conversion, and we know we can do that using molar mass. With grams per mole. So we have from the periodic table 24.305 grams per 1 mole of magnesium. So this allows us to arrive at our answer So we had 19.5 grams of magnesium left over. Excess. So that is the end of this limiting reactant tutorial. Please stay tuned for next time.